Hey students, welcome to the second video of the Gaussian elimination method. This is a second example from the other video. We're going to go ahead and just practice the same process you saw on this previous example. So starting with the system, we're going to convert that into an augmented matrix. So we're going to have 2, -2, 3, +2, 1, 2, -1, 3, 3, -1, 2, and 1. And then from here, remember our goal is to make this matrix have zeros in the corner and the other numbers don't matter. And as I mentioned, the ones no longer need to be created. You could just find the answer with those zeros. So start with zeros on the left side, either 1 or 3. I'm going to go ahead and start with 1. So row 1, row 2, row 3, and I'm going to use row 1, but you could also use row 3, whichever one you want. We just want to make sure we convert them into numbers that they can cancel. So the example I'm going to do is row 1 and row 2. In order for these to cancel, row 2 has to be a -2. So I'm going to do 2, -2 times row 2, and I'm going to add it to row 1. This will result in the new row 2. So I'm going to write row 1 and row 3 the same way that they have them right now. -2, -2, 3, 2, 3, -1, 2, 1. And then the answer to this process will look like -2 times R2. And again, this could be done in your mind if you are good in your mathematical skills. So row 2 times -2 will be -2, -4, +2, -6. So each number on row 2 times that will give you these numbers. Then we're going to add row 1, so +2, -2, 3, and 2. Again, these numbers are from row 1. I'm going to go ahead and add downwards. So the answers I get, I will place them in this value, in this space, sorry. So 0, -6, 5, and -4. Okay, so now I'm going to move on to this corner right here, the 3, and make that a 0, and I'm going to use row 1. So the only way 3 and 2 can cancel each other is if they are converted into a number that they both can become. So 6 is a number that 2 can become and also 3. So I'm going to multiply row 1 times 3, and I'm going to multiply row 3 times 2. However, we need to have a positive and a negative for them to cancel. So in order, it doesn't matter which one you make negative. So I'll just make this one a negative and this positive. And this will result in the new row 3. Because I'm making a new row 3, I'm going to just copy row 1 and 2. 2, -2, 3, 2, 0, -6, 5, -4. And then now I'm going to show the process. Row 1 times -3 is -6, +6, -9, and -6. Row 3 times 2, it's going to be +6, -2, 4, and 2. And we're going to add downwards, so we're going to have 0, 4, -5, and -4. All right, so then now, as I mentioned in the previous example, when we get to this point and we have 2 zeros, we should not consider the first row and just look at these 2. And then how can we make that 4 a 0? So 6 and 4, what number can they both become? They both can become a 12. So the way you're going to make row 2 a 12, and good thing one of them is negative and the other is positive, so you don't have to worry about that. We just need a -12, so we're going to do row 2 times 2, and then we're going to do row 3 times 3, because 3 times 4 is 12. And this is going to create a new row 3. So we're going to write row 1 and row 2 since we're not changing those. And then now let's write the process that we get from this. So row 2 times 2, we're going to multiply each number here times 2. So we're going to have 0, negative 12, 10, and negative 8. And then we're going to do 3 times row 3. So 0, 12, negative 15, and a negative 12. When we add downwards, we get 0 and 0, so that's what we wanted. And then right here we get negative 5, and then here we get negative 20. Okay, so now that we have the 3 zeros, we can either rewrite this matrix as equations, or you can already know that this represents 2x minus 2y plus 3z equals 2, negative 6y plus 5z equals negative 4, and negative 5z equals negative 20. So visualize this as a system of equations that looks like this, where you can use substitution method. So we're going to go ahead and start with the one-step equation, which is this one right here, and that's going to be negative 5z equals negative 20. And then we divide by negative 5, z equals 4. Next, we're going to put that z in that second row. So we're going to put negative 6 y plus 5z equals negative 4. Substitute the z with the 4. And then now we're going to have this right here. And we're going to multiply 5 times 4, and that's going to be negative 6y plus 20 equals negative 4. And then minus 20. So now we have negative 6y equals negative 24. And divide by negative 6. So y equals positive 4. Okay. Last one is using this top equation. So I'm going to write that here sideways because I ran out of space. So it's going to be 2x minus 2y plus 3z equals 2. And I'm going to use the z equals 4 and the y equals 4. So 2x minus 2 times 4 plus 3 times 4 equals 2. And we simplify, so we're going to have 2x minus 8 plus 12 equals 2. And then we're going to have these combined, and we end up with 2x plus 4 equals 2. Subtract 4 on both sides. So 2x equals negative 2. And then we divide by 2, and x equals negative 1. Okay, so all these values, x, y, and z, need to be rewritten in order. So we're going to have the solution of negative 1, 4, and 4. Okay, hope this video helps you.